Sin square A into tan A plus cos square A into cot A plus 2 sin A into cos A equal to tan A plus cot A. Means we have given LHS and prove it is equal to RHS. Means we have to prove equal to this example equal to tan A plus cot A. How will you prove? Let us see. We have LHS sin square A into tan A plus cos square A into cot A plus 2 sin A into cos A. Here you substitute or you put the formula for tan theta and formula for cot theta first. In first step, what is formula for tan theta? We know in practice set 6.1 or some trigonometric formulae, tan theta is equal to sin theta upon cos theta and cot theta is equal to cos theta upon sin theta. This formula we have to use here. Sin square A, instead of theta take as A, so formula for tan A equal to sin A upon cos A. Cos square A, formula for cot is cos A upon sin A plus 2 sin A into cos of A. As here is no any number, it means in denominator is 1. As here is no any number, it means here denominator is 1. As here is no any number, means denominator is 1. We know the algebraic expressions. What is an algebraic expression? A square into A is equal to what? A cube. So, sin square into sin A, we can write it as sin cube A. Because we know that A square into A is equal to A cube. 1 into cos A is cos A. Same way, cos square A into cos A is cos cube A. 1 into sin A is sin A. Plus 2 sin A into cos A upon 1. Here, solve these two terms first. Here LCM equal to cos A into sin A. Because we know the formula 1 by A minus 1 by B is equal to LCM is AB, then take cross multiplication B minus A or B plus A. If here is plus, then here is B plus A. In this way, LCM is cos A into sin A, take cross multiplication, sin cube A into sin A. Again, A cube into A is A4. In this way, we can write as sin cube A into sin A is equal to sin 4A. Cos A into cos cube A is cos 4A. And here is second term, sin A into cos A upon 1. Solve in same way. Here LCM is equal to cos A into sin A into 1 is cos A sin A. Take cross multiplication. 1 into sin 4A cos 4A is sin 4A plus cos 4A plus 2 into sin A into sin A is sin square A. Cos A is cos square A This is the expression in the form a plus b bracket square is equal to a square plus b square bracket square is equal to a4 plus 2a square b square plus b4. This expression is in this form. See, sin 4a plus 2 sin square a cos square a upon cos a into sin a. This is the expression in this form. So we can write it as a square means sin square a and b square means cos square a. So we can write it as sin square a plus cos square a bracket square upon sin a into cos a. Again, we know that trigonometry identity, sin square theta plus cos square theta is equal to 1. So sin square a cos square a is equal to 1 square sin a into cos a. 1 square we can write it as 1 upon sin a into cos a. Again, for this one you put identity as sin square a plus cos square a upon sin a into cos a. Split this, we can write this term as sin square a upon sin a into cos a plus cos square a upon sin a into cos a. This side cancel with this sign, this cos cancel with this cos. So here is sin a upon cos a and here is cos a upon sin a, and we know the formula sin a upon cos a is equal to tan a and cos a upon sin a is equal to cot a. It means RHS. In this way we can prove this sin square a into tan a plus cos square a into cot a plus 2 sin a cos a is equal to tan a plus cos a. Next example is prove that sec square a minus cosec square a equal to 2 sin square a minus 1 upon sin square a into cos square a. This is given, we have to prove it is equal to 2 sin square a minus 1 upon sin square a into cos square a. Let us see, this is LHS, take LHS and prove it is equal to RHS. We have LHS sec square a minus cosec square a we have formula, replace this sec square a by its formula. We have formula for sec theta is equal to 1 by cos theta. You replace this sec square a by this formula as 1 upon cos square a. Instead of theta, here is a, so formula for sec square a equal to 1 by cos square a. And again we have formula for cosec theta is equal to 1 by sin theta. You replace this cosec square a by this formula as 1 by sin square a. In algebraic expression, we have formula 1 by a minus 1 by b equal to ab, and we write it as b minus a. Take cross multiplication. This formula we have to use here. Here LCM is cos square A into sin square A. Take cross multiplication. 1 into sin square A is sin square A minus 1 into cos square A is cos square A. Again, we have some trigonometric formulas. Again, we have one formula, sin square theta plus cos square theta equal to 1 is a trigonometric identity, well-known trigonometric identity. And from this identity, we can write as cos square theta is equal to 1 minus sin square theta. So instead of this cos square A equal to, we can write it as 1 minus sin square A for this formula. Cos square A into sin square A. Multiply this minus 2, this bracket. Here is minus 1, minus into 1 is minus 1, minus into minus is plus sin square A upon cos square A into sin square A. As this is sin square A, this is sin square A, here is plus, it means it becomes as 2 sin square A minus 1 upon cos square A into sin square A equal to RHS. In this way, we prove as sec square A minus cosec square A is equal to 2 sin square A minus 1 upon sin square A into cos square A by the application of some trigonometric formulas which we know in previous practice set. Our next example is prove that sin theta into 1 minus tan theta minus cos theta into 1 minus cot theta is equal to cosec theta minus sec theta. This is one more challenging example. Take how to solve. Take LHS and you prove it is equal to RHS. What is LHS? Sin theta into 1 minus tan theta minus cos theta into 1 minus cot theta. You write here formula for tan theta and cot theta first. And we know the formula for tan theta is equal to sin theta upon cos theta, and formula for cot theta is cos theta by sin theta. You write here formula for tan theta is sin theta upon cos theta. And formula for cot theta is cos theta by sin theta. As here is sin theta into this bracket and cos theta into this bracket, it means in second step you multiply sin theta to this bracket and cos theta to this bracket. So sin theta into 1 is sin theta. So multiply it. Sin theta into sin theta is sin square theta upon cos theta. Cos theta into 1 is cos theta. Cos theta into cos theta is minus into minus is plus cos square theta upon sin theta. Now you solve these two terms first and these two terms first. Then as here is no any number means 1 is denominator, as here is no any number means 1 is denominator. So LCM is here. 1 into cos theta is cos theta and term as cos theta sin theta minus sin square theta. 1 into sin square theta is sin square theta. Here is take this plus term first and then solve. Cos square theta upon sin theta minus cos theta upon 1. In same way, cos theta sin theta minus sin square theta upon cos theta. You solve as LCM is equal to sin theta. Take cross multiplication. 1 into cos square theta is cos square theta minus sin theta into cos theta. Solve this as LCM equal to cos theta into sin theta. Again take cross multiplication. Sin multiplied by this sin to this cos theta sin theta minus sin square theta and cos to this bracket cos square theta minus sin theta into cos theta. So here is sin theta into sin theta equal to sin square theta into cos theta minus sin theta into sin square theta is sin cube theta, cos theta into cos square theta is cos cube theta minus cos into cos is cos square theta sin theta into cos square theta. From these two terms, take sin square theta common. From these two terms, take cos square theta is common. So here is sin square theta cos theta minus sin theta. Here is sin theta. Sin square into sin is sin cube. So here is sin theta. Take here is cos square, here is cos square. So take cos square common, and here is cos theta because cos square theta into cos theta means cos cube theta. So here is cos theta minus sin theta upon cos theta sin theta. From these two, take here cos theta sin theta common minus sin theta common. So here is sin square theta and here is plus cos square theta upon cos theta into sin theta. We know the identity sin square theta plus cos square theta equal to 1. So cos theta minus sin theta into 1 upon cos theta into sin theta. So here is 1 into this is equal to cos theta minus sin theta upon cos theta into sin theta. Same way you divide this by both term as cos theta upon cos theta into sin theta minus sin theta upon cos theta into sin theta. We can write this cos theta minus sin theta upon cos theta into sin theta as cos theta upon cos theta into sin theta and sin theta upon cos theta into sin theta. This cos get cancelled. This sin cancel with this sin. So here is 1 by sin theta and here is 1 by cos theta, and we know that 1 by sin theta is equal to cosec theta and 1 by cos theta is equal to sec theta is equal to RHS. Means we prove it is equal to cosec theta minus sec theta. This LHS is equal to RHS. In this way you solve such type of example in exam. Example Prove that sin 6a plus cos 6a equal to 1 minus 3 sin square a minus cos square a. This is one more challenging example which may be or frequently asked in the exam. So watch it carefully. To solve such type of example, some algebraic formula we have to use, and by using such formulas we can easily solve such type of example. If you know the formula, which formula we want to know? We want to know the formula to solve such type of example is a plus b bracket cube, and we have formula for that: a cube plus b cube plus 3ab into a plus b. We know very well, we have seen in 8th standard, in 9th standard, in 10th standard. This formula, if you know, then you easily solve such type of example. But you have to do some steps. Means our example is in the form of sin 6a plus cos 6a. You have to convert it in the form of a cube and b cube. How will you convert? We write sin 6 as sin square a of cube. We know the rule of indices: a to the power m to the power n means a to the power mn. 6 we can write as 6 power, we can write as sin square a to the power 3 by this rule of indices. And cos 6 we can write as cos square a to the power 3. Means we write this LHS as sin square a to the power 3 cos square a to the power 3 without any change in the example. Means you have to split this power 6 in this form by rule of indices. So from this formula we can write as a cube plus b cube is equal to a plus b bracket cube, take this term to this side, minus 3ab a plus b. Means from this formula we get formula for a cube plus b cube as a plus b bracket cube minus 3ab in bracket a plus b. So you write here this formula, apply here this formula. A means what? A means sin square a. B means what? Cos square a. You apply this formula for this here. A means we have formula here: a cube b cube is equal to a plus b bracket cube minus 3ab in bracket a plus b. Here a means sin square a, so we write it as sin square a plus cos square a. A means sin square a, b means cos square a cube minus 3, a means sin square a, b means cos square a in bracket sin square a plus cos square a. We know very well identity: sin square theta plus cos square theta is equal to 1. So for this sin square a plus cos square a we write as 1 cube minus 3 into sin square a cos square a. Again this is equal to 1 because we know that sin square a plus cos square a is equal to 1 by the identity of trigonometric function. So 1 cube is 1 minus 3 sin square a into cos square a. So our RHS, it is equal to RHS. In this way, from this LHS we prove it is equal to RHS. Very simple way you have to prove such type of example.